So hello everyone, welcome to today's daily Leetcode challenge. Today is day 13 and we have a symmetric tree problem. So let us see how to solve this. Today we have easy problem with us. Question number 101, symmetric tree. You must be knowing what a symmetric tree is. So for example in this case, this diagram, okay. So if you keep a mirror here below the one, a vertical mirror, so it will be like a replication of each. So 2 is here, 2 is also present here, 3 is present here as a child of 2, as a left child of 2. In this case 3 is present as a right child of 2. Similarly 4 here is a right child of 2. In this case 4 is a left child of 2. So that you can see there is a symmetry here. That's why it's called a symmetric tree. So we have to verify if it's a symmetric tree or not, and we have to return true if it's a 1. And in this case you can see the elements are the same in the left of 1 and in the right of 1. The elements are the same, but the order is not the same. That's why we are getting the answer as false. Uh, yeah, see, as you can see, the left subtree of 2 is null here. So the right subtree of 2 in this one should be null as well. But in this case, it's not so. That's why it's not a symmetry. As you can see on the diagram itself, if you keep a mirror below 1, it won't be symmetric. Okay, here if you give, it will be like exact symmetry, like a mirror image of it. The right subtree of 1 should be a mirror image of the left subtree of 1. That is the basic idea here. Okay. And the number of nodes are not very high. It's not only 10 to the power of 5, 4, or 3, something like that. It's small only. And this value actually doesn't matter to us. Yeah. So we are asked to solve it recursively and iteratively. So from the first thing that comes to my mind is DFS and VFS. We will have to go through each of them and we will have to understand which elements are present in each of the levels. See, it's a level association. For example, 2 is present in the level 1. What level means is, at level 1, when I say, it means a distance 1 from the root. How many elements are present? 2 is present, 2 is present. That means, yeah, in this level, the symmetry is maintained. At level 2 means a distance 2 from the root. That means this one, 3 and 4, 4 and 3, like this. At this level, if the symmetry is present, like this, if an odd level symmetry is present, that means the tree is symmetric. That means both left and right subtree of the root are symmetric. Only then we can return true here. Okay, that's the basic idea of the question. I'll give you a sample diagram here. For example, this is my tree. Okay, one is the root. It has two subtrees, and it starts with 2 and 3. 2 has only one child, which is 4, and means there is nothing here. Okay, and means there is nothing here. Similarly 3 has this thing. It has nothing in the left, and it has 5 in the right subtree. I'll just increase the font. Go through this tree once and means nothing. Okay, so now I will be making it a, like, I will be using data structure like a mapping means there will be key and value pairs. Here the key refers to, you know here the key refers to the level, and the value refers to the elements from left to right order. Okay, so at level 0, which is the root, I have only one element, 1. At level, how to make this I will see in the code, but just to understand how it works, at level 1 means a distance 1 from the root. We have two elements, 2 and 3. Okay, at level 2 means a distance 2 from the root. We have, as you can see, distance 2 means 1 to 2 there is distance 1, 2 to 4 there is distance 2. So at all the elements present in this level are distance 2. Okay, there has to be individual symmetry in this each of the levels. Only then we can conclude that the whole trees have a subtree. Means the whole tree has symmetry. So it's 4 and 5. Okay, we'll have to consider the data structure first. So now the question is how to solve it. See, if I will check, like, first of all, each of the values here should be even numbered. What that means is, for example, for it to be symmetric, for example, suppose this 5 is not there, that means the left subtree of 1, this part 2 and 4, this has more number of elements than this subtree, then obviously they can't be symmetric. So first of all, at each level it should be a even numbered value, a value array. Okay, that means the elements present in the left and right are the same. Only then we can go for checking at least. If the value itself is missing, there's no meaning of checking. Okay, that is the first thing. And the next point is the value should be matching. For example, here 4 is present. If here 4 is present, then in this level 2 I can see it's symmetric. Similarly, here 2 is present. If here also 2 is present, I can see it's symmetric. And one more thing is, suppose instead of 5 here I get 4, So okay, let us make it null. And here suppose 4 comes. See, 4 is present here also, 4 is present here also, but still they are not symmetric. So okay, forget this layer. Just consider this. I'm talking about level 2. Still it is not symmetric. What it means is here n should come, here 4 should come. Okay. Then it will be symmetric. Symmetric means if you keep a mirror here, it should come. Yeah. If mirror this cursor, it should be symmetric. Coming to the coding part, automatically data structure will see first. I am taking a simple dictionary. Okay. Here key will be the distance from the root. We call it a level, and the value will be to store elements. Okay, it's the value, not the value will be to store the elements at each level from left to right. Left to right in the sense, for example, 2, then 3, 4, and then 4. 4 and 4. Okay. I've modified this, but here it was 5 earlier. Here it was null earlier, and it was 5 earlier. Yeah. So it will look like this. I will print and show as well. We are using a function here, DFS. DFS is depth first search. What depth first search means is that first I will start from a root, then I will go to the leftmost subtree, and again I will go to its leftmost subtree. When there's nothing more left, I will come back to 2. From 2, I will be going to its right subtree. Again, when nothing is left, I will come back to 2. From 2, now both the subtree are covered, so I will come back to 1. Now for 1, the left subtree is fully covered, I will come back to 3. For 3, I will go to its left subtree first. There's nothing below n, so I will go back to 3. Now for 3, left subtree is covered, I will come back to 5. Similarly, for 3 both are covered, I will come back to 3 again, and I will return back to 1. For 1 also both are covered, so yeah, we'll end the solution here. So default function will complete it here. Here instead with root I am passing another parameter level. Level is actually the distance from the root. Initially it will be 0 because first element will be root, and as we are increasing, as we are going below, I will be increasing the level by 1. So yeah, I'll be this is the function call. It's a recursive function. We are implementing DFS here, not BFS. DFS means for one child, we'll be exploring each of its left child, then right child, like that. Okay, that is DFS approach. You can just Google it once if you're not very through with it. Now, for example, if I find that a root is null, when this can happen. For example, I am at 2. I am calling the defense function for the right subtree. This is nothing here, okay? In that case, what see in the question they will not give this. Below 2 in the left side, for example, in this image, the left 2 to the left of 2 there is nothing. There is no left subtree of 2. So we only have to implement this n, okay? How to do this? This is the part where we are doing it. If this is not present in the level, if this level is not present in the level, first implement the level, create a sub array, means create an array, and in this array put element n. If the level array already exists, for example, when you are coming to this n, this array already exists. Okay, this array already exists with element 4 and n. So we'll be implementing this n. We'll just append this n to the array at level 2. Okay, this is the one. This is when root is done. That means there is no element in that. Now coming to when there is a value here. Okay, after that we are returning. Okay, so all this will be implemented only for those nodes which have a value. If there is a value, I will make it as a string and I will append it in my array. If there is no array, I will create one. If there is array, I will append. How it looks, I will show you first. Yeah, as you can see, we are talking about yeah this image. So level 2, that means the distance 2 from the root. This is how it will be 3 4 and 4 3. It will be exact in the order in which it is present. And if yeah, we can go to this case. This is the second case. Okay, This is the second case. If we come to this, we can see 3 is not the first element in that level. That means n is coming first. And when it comes to the right subtree, here again n and then 3. Okay, that's how it will be done. Now, once see how the values are appended here. They are as a string. See, 3 here is as a string. Okay, we can't keep the number here because you can keep the number maybe, but I am keeping it as a string here. Then we are calling the DFS recursively for the left subtree first. That means all the left subtrees first will be, it will be processed. Only then we will come to the right subtree. Here I am doing a level plus 1 at each level. Okay. So for each of them, as you can see, if the level is not present, we'll clear that level array first. If the level is present, we'll simply append. Okay. The same is done here. I'm creating level array first if it's not present. And if it's present, I will just appending here. Now comes the processing part. Okay. I'm going through the arrays. So for each key, and I is the key here. The elements array is the value here. Okay, I is the level number, and elements array is the elements present left to right in that level. If I is 0, that means the case of root. Here is the root case. Simply avoid it because we don't want to see the symmetry in the root level. I'm taking the length of that elements. See here, element means this array. Okay, this is the array for elements. If it's not even number, return false. I have told you previously also why. If the number of elements is more in one side, then obviously there can't be symmetric. So simply return false without any processing. Okay. Then what I am doing is I'll be going to the middle of the array. For example, there are 4 elements are present, and in this case is 4. Okay. I will go till 2 elements. Index 2. Index 2 means 0 and 1. This is 0. This is 1. I will go and I will compare it to the corresponding element from the last. I will compare 4 with 5. If it matches, I will compare n with n. Okay. Corresponding element from the last. 0th element from the first with 0th element from the last. First element from the starting to the first element from the right. Okay. Like this we'll be comparing. So I'm taking the mid value. This symbol is used if we want the answer in integer form. Okay. This symbol is used. This double divide symbol. For index in range m, I'm taking the indexed element. That means let us say ith element from the left with the ith element from the right. Okay, if they are not same, I'm returning false. If they are same, I'm simply continuing further. So in case if at all levels we have even integers and if none of the values are mismatching, only in that case I'm returning true. Okay, so if you have any doubts, you can please comment below. That I can't understand how which part you will be having doubt further. So if you can comment, only I can know. So I'm just running this code. It's matching all the test cases. So yeah, as you can see, I'm printing it here. It will be consuming some of the processing power. I will comment it out. I will run here. Yeah, it's getting accepted. Finally, let us submit. So yeah, that's all for today, friends. If you like this video, please like and subscribe. Thank you.